So, hi everyone, look at this question. Now in this question, just draw this cube first. Now if you read the question carefully, in this question, one cube is given like this, and the side length of the cube is A. And they have mentioned that a line charge of A by 2, if I draw, a line charge of length A by 2 is capped at the center of an edge BC. ABC हो गया, okay? Now at the center, center means center is this center of an edge BC. Here we have placed our line charge. Okay, center. And the length of this line charge is A by 2. Its length is A by 2. A by 2. Now what they are asking, if the density of line, it is like linear charge density, lambda coulomb per meter per unit length. Okay. Then they are asking, then the total electric flux through all the faces of the cube will be. Simply they are asking how much flux that is linked with all the faces. Okay, flux means number of electric field lines passing normally. Okay, that is only number of electric field lines. That's only. Now see how to calculate like how much, because now in this question if you look at carefully, some flux is also going here. Okay, of this charge, some flux is going here also, like this side also, because it is not close. Okay, so we have to first, before applying the Gauss theorem, we should know the concept of Gauss theorem. Just look at this. We have to make our surface to be close like this, like this. Our charge is here. Okay, linear charge density is here. This is our charge. Now symmetry. We have to see the symmetry around this charge. Clear? Around this distribution of charge, we have to look at the symmetry. So what I will do, I will make the symmetry in such a way that our charge should be at the symmetry means charge should be inside the closed surface. That's only. We have to make a closed surface. Before applying the Gauss theorem, we have to consider a closed surface. Now, you can make a closed surface in various ways, but you have to be understood. We have to make a closed surface in such a way there should be a symmetry. Clear? Then how we will make a symmetry? We will consider, if I consider one cube below that like this, if I consider one cube below that, then will I get symmetry? Okay, you can say it is symmetry like this. It is same as that. Okay, in the right, this distance, same symmetry around this charge in the right, but there is no symmetry. You can check here, symmetry is this. Is there any symmetry in this like this? No, here nothing is here. Okay, then we have to think what you will do. There is lacking of symmetry here, so I will consider one cube here also, like this. I will consider one cube. Okay, one more cube downside. Clear? So around, if you ask me how many cubes, there are four cubes. So total flux through four cubes will be 5. Through one cube, 5 by 4. And what is 5? 5 is charge enclosed by the closed surface. So how much charge? This is a flux linked with single cube. Single cube. Understood? Phi is total flux. Total flux. Total flux is Q inside. How much inside? Linear charge density is given. Lambda. Its length is A by 2. Lambda multiply A by 2. This is the charge inside the closed surface. So how much flux is linked with single cube? Single cube means all the faces of the cube. It is lambda A by like this. So what is the answer? Phi will be phi from the single cube. That is lambda A by 8 epsilon naught. It is epsilon. Okay. So which option is correct? Option 1. So before applying, again I am saying, if you want to apply Gauss theorem, surface must be closed. First thing, there should be symmetry. It is useful in that case. We can apply Gauss theorem in whether it is symmetry or not. But it is more useful when there is symmetry. Is it clear? So any doubt still you have, you can ask. So from single phase, how much? Lambda A by 8 epsilon naught flux is going to linked with all the faces of the cube, means single cube, that's all. Okay, I hope you understood. Still you can ask me, but I just want to tell again, whenever you are considering the closed surface, you can consider any shape, whatever you want. But remember one thing, when you are considering a closed Gaussian surface, there should be a symmetry around this charge. Clear? Around this chart there must be a symmetry, then only it is very useful. Okay, thank you.